Hello viewers, you are welcome to your favorite learning channel, that is Royal Learning Channel. Today is our third day on velocity time graph, and we are going to be learning how to sketch a velocity time graph from word problem. So let's look at the question on the board. It says that a car starts from rest and accelerates uniformly for 5 seconds until it attains a velocity of 30 meters per second. It then travels with uniform velocity for 15 seconds before decelerating uniformly to rest in 10 seconds. Question number 1 says that sketch a graph of the motion. 2. Using the graph above, calculate Roman figure 1, acceleration during the first 5 seconds. Roman figure 2, deceleration during the last 10 seconds. Roman figure 3, the total distance covered throughout the motion. So to sketch a velocity time graph from word problem, the first thing that you need to do is to sketch your velocity axis on the vertical line and your time taking axis on the horizontal line, because we call this what? A velocity time graph. So let's do that first. Your vertical line is your velocity axis in meter per seconds, while your horizontal line is your time taking axis in seconds. So that is the first step to take. So let's follow our instruction now. A car starts from rest. A car starts from rest. So our initial is what? Is 0. It will start from 0. When they say that an object starts from rest, it will start from 0 and accelerates uniformly. And accelerates uniformly. I want to explain something here. When they say that an object accelerates uniformly on a velocity time graph, it must not go on a vertical line. It must not travel what? On a vertical line, because if it travels on a vertical line, it will only cover the what? The velocity axis. It will only cover the velocity axis, and we call it a velocity time graph. So it must not what? Travel on a vertical line, then it must not travel what? On an horizontal line, because it will only cover the time taking axis. So when they say that an object accelerates, it will go in a slanting form. It will travel in a slant. So it accelerates from what? From rest. So the resting position is what? Is 0. It will go in a slanting form. So accelerate uniformly for 5 seconds. So we are going to trace it to what? To the time taking axis. So this is 5 seconds. Then it then travels with for 5 seconds until it attains a velocity of 30 meters per second. So it travels for 5 seconds at what? 30 meters per second. So let's trace it to velocity of 30 meters per second. So we are going to trace this to what? To velocity axis. So this place is what? Is 30 meters per second. This is our 30 meters per second. So let's read further. It then travels with uniform velocity for another 15 seconds. It travels on this same velocity. It travels on this same velocity for another what? 15 seconds. So for another 15 seconds now, we are going to add that 15 seconds to this 5. So this place will be 20. 15 plus 5 will give us 20. So distance between 5 and 20 is 15. Now let's read further. For 15 seconds before decelerating. Deceleration means coming down. Before decelerating uniformly to rest in 10 seconds. It decelerated to rest in 10 seconds. So it will come to rest in the next 10 seconds. So it comes to rest in the next 10 seconds. So we are going to add that 10 to 20. So this place will be 30. Will be 30 seconds. So distance between what? 20 and 30 is 10. So you still label your what? Your time taken in what? In seconds. So we sketch the what? The velocity time graph from this word problem. So let's solve the question under it. So sketch a graph of the motion. We have done that. Roman figure 2. Using the graph above, that is this graph, to calculate one, acceleration during the first 5 seconds. You calculate acceleration during the first 5 seconds. Now, the first 5 seconds is from 0 to this place. From 0 to 5, that is our first 5 seconds. So, which means that for that first 5 seconds, we need this what? Triangle. We are going to need this triangle for the first 5 because the 5 seconds covers 0 to this, down to this place. It covers this what? Triangle. Now, to calculate acceleration, we are looking for what? Acceleration during the first 5 seconds. So, from here down to this place, during the first 5 seconds. Now, to calculate acceleration, we are going to use A equal to change in velocity divided by the time taken. That is the formula for calculating acceleration. Then we want to calculate our acceleration in the first 5 seconds from here down to this place. So we need what? V is our final velocity. So we come to the velocity axis. Our final velocity is what? Is 30. Our final velocity is 30. So which is equal to 30 minus our initial velocity is the starting point on this what? Velocity axis, which is equal to 0 minus 0 divided by the time taken. The time taken for the first 5 seconds, that is from here down to this place, the time taken is 5 seconds divided by 5. So which is equal to 30 minus 0 will give us 30 divided by 5. So our acceleration will give us 30 divided by 5 will give us what? 6. 6 meter per seconds square. So we have answered the first question. So number 2, Roman figure 2 says that deceleration during the last 10 seconds. Deceleration during the last 10 seconds. Then the opposite of acceleration is deceleration. So we are still going to use the same formula to find our deceleration, to calculate deceleration in the what? In the last 10 seconds. So in the last 10 seconds now, we consider the last 10 seconds on the graph. So from 20 to 30. So from 20 to 30, we have 10 seconds. So this is our last 10 seconds because, and this is where it decelerated. So we are looking for deceleration during the last 10 seconds. So the graph decelerated from this place. It decelerated from this place. So this is the starting point for that deceleration. So from 20 to 30 is 10. So we are going to use this triangle to answer our deceleration. So Roman figure 2. Roman figure 2. Now, deceleration is the same thing as acceleration, the opposite of acceleration. You are still going to use the same formula for calculating acceleration. So which is equal to change in velocity divided by the time taken. So our A will now be equal to, so what is the final velocity? The final velocity. So we are going to look at the height of this what? Deceleration, where the what? The car decelerated. So where the car decelerated. So the final velocity is 30. So that is 30 minus, so the initial velocity where it decelerated. So when you trace it down to this, that is 0. So the starting point is what? Is 0 divided by the time taken for the last 10 seconds. So don't forget that we are using this triangle to look for our deceleration in the last 10 seconds. So from 20 to 30, distance between 20 and 30 is what? 10. That is 30 minus 20 will give us 10. So our time taken is what? Is equal to 10. So which is equal to 30 minus 0 will give us 30 divided by 10. So therefore our deceleration is equal to 30 divided by 10 will give us 3. So 3 meter per second square. So that is Roman figure 2. Then let's move to Roman figure 3. So we are looking for the total distance covered throughout the motion. The total distance covered throughout the motion. So to calculate the total distance covered on a velocity time graph, you are going to use the what? The shape that appear on the diagram. So the total distance covered is equivalent to the shape that appear on the diagram. So Roman figure 3. Total distance equal to, so what is the shape what's the name of this shape that appear on this diagram? This is a trapezium, so equal to the area of a trapezium, so which is equal to, so our total distance covered now, total distance covered equal to, so what is the formula for calculating area of a trapezium? That is 1/2 times a plus b times height. 1/2 times a plus b times height. So which is equal to 1/2 into bracket. What is your A? Your A is the first parallel line on the what? On the trapezium. This is our first parallel line. That is from here down to this place. So from here to this place is equivalent to what we have from here down to this place. So 20 minus 5 will give us 15. So distance between 5 and 20 is 15. So our A is equal to 15 plus B. B is the second parallel line. This is the first parallel line. Then this is the second parallel line of this trapezium. So down to this point 30. So the length of this parallel line is 30. So plus B is what? Is 30 times height. So the height of the trapezium, the height is from here down to this place. So which is 30? The height is 30. So multiply by 30 equal to 2 here 1, 2 in 30 will give us 15. So 15 plus 30 will give us 45. Will give us 45. So 45 times 15 will give us 675. 675. So 675 what? We are looking for total distance. Total distance will be in what? In meter. In meter. So the total distance is equal to 675 meter. So we have come to the end of this class. If you are watching me on YouTube and you have not yet subscribed, kindly click on the subscribe button to follow my YouTube channel. Then if you are watching me on TikTok, click on the link in my bio. It will take you to my YouTube channel. Don't forget to share this video, like and leave comments. See you in my next class. Bye.